Hi class, this section is on properties of division. So the division algorithm for polynomials looks like this. You have f of x is equal to p of x times q of x plus r of x, where f of x is your polynomial, and you're dividing by p of x, and q of x turns out to be the quotient, and r of x is your remainder. So we can write that. This is your quotient. This is the remainder. All right, so let's see what we have for the first example. Find the quotient and remainder if f of x is equal to that function and it's divided by p of x. You can think of this as a dividend. You can call this the dividend. The divisor. All right, so let's go ahead and do this. We're going to have to do long division, so I'm going to set it up as a long division problem. 3x to the fourth plus 2x cubed minus x squared minus x minus 6 divided by x squared plus 1. So the way I like to do this, I like to do my scratch work off on the side. So what I like to do is I always take the first term here divided by the first term here. So that's going to look like this, 3x to the fourth divided by x squared, and that will be 3x squared, and that's going to go up in the quotient. That's your first term, 3x squared. Then you need to multiply, and that goes underneath. So when you multiply, that's going to be 3x to the fourth, and that's going to be 3x squared plus 3x squared. And then we're subtracting. So when you're subtracting polynomials, you have to put parentheses around the polynomial, and then you need to distribute the negative sign. So this becomes negative, and this becomes negative. So I'm just going to erase the parentheses and change those to both be negative, negative, negative. And now when we add down, you're going to get cancellation here and here. And now this gives us negative. Actually, you have to be very careful. These are not like terms. This is an x squared. This is an x cubed. So what you want to do is you want to actually scoot this over to the side, minus 3x squared. And so it's aligned with the like term. This one will just drop down. So that'll be 2x cubed. When you combine those, that becomes negative 4x squared. And you can bring the rest of the polynomial down. And then we're going to repeat that algorithm. So we're going to go through the next iteration. So you take the first term divided by the first term again. So that's going to be 2x cubed divided by x squared, which is 2x. And that's the next term in your quotient, positive 2x. And then you repeat the steps, which means multiply. So that's going to be 2x cubed for the first term. The next one will be positive 2x. And same thing, you subtract, which means you need to distribute the subtraction into this polynomial. So once again, these will both become negative after I distribute. So I'm going to change that now to negative, negative. And once again, this is not aligned, so you want to align this under the like term. So that's going to be negative 2x under the x. And then these will cancel, and now you can bring down this term, combine those two like terms, that's negative 3x, and bring down the negative 6. And we can go through this iteration one more time. First term divided by first term will be negative 4x squared divided by x squared is negative 4, so that would go up here. And we distribute again. That'll be negative 4x squared minus 4. Make sure it's aligned. Parentheses, subtract, distribute the subtraction. Now this will become positive, and this will also become positive. So I'm going to erase that and convert that, change it to a positive. These will cancel, and our remainder will be negative 3x minus 2. That is our remainder function. So our quotient function is up above. It's 3x squared plus 2x minus 4. And our remainder function is the bottom, minus 3x minus 2. And that does it for that problem. So now we have what's called the remainder theorem. So if a polynomial f of x is divided by x minus c, where c is a constant, then the remainder is f of c. So let's see if we can confirm that with this next example of given this function, they want us to use the remainder theorem to find out what f of 3 is. All right, so we can figure it out one of two ways. You can simply plug in 3 into the function, and that should be the same thing as dividing this function by x minus 3, because c is 3. So I'll say let c equal to 3. So if we do long division, we'll have x minus 3 outside. Inside, we'll have the function f. So if we do the long division, I'll do my scratch work again. Remember, we do the first term divided by the first term. That would be 2x cubed divided by x, which is 2x squared. And then we distribute. All right, and that's going to be 2x cubed minus 6x squared. This time they do align. Minus, subtract, distribute your negative. So that will become minus. This will become positive. So minus and plus. Cancel. This becomes 10x to the second and bring down the rest of the terms. And then let's repeat that process. 10x squared divided by x is 10x. So plus 10x. And then we multiply once again. That will be 10x squared minus 30x. Subtract, which means change the signs after we distribute. This becomes minus plus. So minus plus. Cancel these two terms out. Now we have positive 27x, bring down the 1. And we can repeat this step one final time. First term divided by first term is 27x divided by x is 27. And so when you distribute or multiply here and here, you get 27x minus 81. And then we subtract, which means distribute. That becomes minus and plus. Minus and plus, and we are left with 80 is our remainder. So our remainder is 80. We can confirm that by simply substituting 3 into the function, and that'll verify that this remainder theorem is actually true for this case at least. So let's plug in 3 into the function. You're going to get 2, 3 cubed plus 4, 3 squared minus 3 times 3 minus 1. And if you work that out on the calculator, you should get 16 plus 9 times 4 is 36 minus 9 minus 1. That would be 42. So I did something wrong here. Oh, that's because this is not equal to 16. That was my mistake. 3 cubed is 27. 27 times 2 is 54. So let's try that again. And now it does equal 80, as you can see. So there are two ways to do this. You can simply just plug in 3 into the function to find the remainder, or you can actually do the long division, which is a little bit longer or more work. All right. There's the factor theorem, which says that a polynomial f of x has a factor of x minus c if and only if the remainder is equal to 0. So let's see if this is true for this example. Show that x minus 2 is a factor of this function. Well, we can use this theorem, the factor theorem. So if we substitute, well, c has to be 2 in this case. Let c equal 2. As you can see, c is equal to 2 here. Then the remainder will be f of 2, which is 2 to the third plus 2 squared minus 11 times 2 plus 10. Work that out. You should get, so that's going to be 0. So what the factor theorem says that if f of c is equal to 0, which is exactly what we got, then that means that x minus 2 is a factor of the polynomial. So we can say, therefore, x minus 2 is a factor of f of x. And that's by the factor theorem. So once again, if you can show that f of c is equal to 0, then that means that x minus c is a factor of the function. And so we've shown that x minus 2 is a factor of the function because f of 2 is equal to 0. Find a polynomial f of x of degree 3 that has zeros, negative 3, 0, and 4. So to find a polynomial of degree 3 with these zeros, we have to work backwards. So what you can do is you can set x equal to negative 3 is 1, 0, x equal to 0 is a 0, and x equals 4 is a 0. So since these are the three zeros, then you can write these as factors by adding 3 to this side, to both sides actually, plus 3. That'll give us x plus 3 equals 0. This one's already in the form that we need it to be. This one you can do the same thing by subtracting 4 over, and that leaves us with x minus 4 equal to 0. Then we take these three factors and we multiply them by one another. I'm going to put x as the first factor, x plus 3 is the second factor, and x minus 4 is the third factor. And that is going to be our polynomial. All right? We can still expand this out by multiplying it. So let's go ahead and do that. I'll start by multiplying these out. And so if I do that, I'm going to get x squared minus x minus 12. And then we can distribute the x. So our final function will be f of x is equal to x to the third minus x squared minus 12x. And that is a polynomial of degree 3 with these three zeros. The next example is asking us to use synthetic division to find the quotient and the remainder of the polynomial when it's divided by x minus 3. So this is the way synthetic division works. You take the divisor, which is x minus 3, and you set it equal to 0 to figure out what c is. Well, c is going to be positive 3. And you put that in the upper left corner in a box, whatever your c is. I'm calling it c because that's the notation, the letter that they use for that situation. But that's what gets placed into the box, and then you take the coefficients of their polynomial and you write them out. So the first coefficient is negative 2. Notice that the x cubed term is missing. So because there's no x cubed, we have to put a 0 in its place. And then the x squared term is missing. Same thing, you put a 0 in its place. The x term is 10, and the constant coefficient is negative 3. So just be very careful. If you see missing terms in your polynomial, you have to remember to put placeholders, 0 as placeholders. Right now, we draw a straight line below these numbers, and then you drop the first number all the way down, and then you begin to multiply these two numbers, which is negative 6, and then you add, which is negative 6. Then you multiply these two numbers, negative 18, and then you add negative 18. Then you multiply, that would be negative 54, and then you add, which is negative 44, and then you multiply, and you get negative 132, and then you add and you get negative 135. This last number is our remainder. So this is our remainder. So that's what they wanted to find. They wanted the remainder, which is negative 135. This turns out to be your quotient. This is the constant term. This is the x term, x squared term, x cubed term. Which makes sense because if you take a 4th degree polynomial and you divide it by a 1st degree, you should end up with the 3rd degree, which is exactly what you end up with. Constant x, x squared, x cubed. So I'll write it out even though they're not really asking. Oh yeah, they are asking for the quotient function. So let's write that out. Q of x is negative 2x to the third minus 6x squared minus 18x minus 44. That is a quotient function. If f of x is given as that function, use synthetic division to find f of 1/3. Well, notice that c is already given to us. That is your c. So that goes into the upper left box. The coefficients are 27, 0 for x to the fourth, 0 for x to the third, 2 for x squared, 0 for x, and 1 for the constant. Draw our straight line, drop the first number, and we multiply. That's going to be 9. And then we add. We multiply, that's going to be 3. Then you add. Multiply, you get 1. Then you add. Multiply, you get 1. Add. Multiply, you get a third. Add. You get 4/3. 1 plus 1/3 is 4/3. So the remainder is 4/3. So that is the answer by the remainder theorem. We know that f of c is equal to the remainder, which in this case is 4/3. We can verify that by plugging in 1/3 into the function and using our calculators to see if we get 4/3. So let's do it that way as well. F of 1/3 directly would be 27, 1/3 to the fifth, plus 2 times 1/3 squared, plus 1. So let's use our calculators to find out what that is. And I'm getting 1.3333, which is the same thing as 4/3. So it does give us the same value as the remainder when we do synthetic division. So this is just to check to make sure that our answer was correct, which it checked out. All right, the last problem is a synthetic division to show that 3 is a 0 of the polynomial. Well, in order to show that 3 is a 0, that means that the remainder has to be 0 when you do synthetic division. So that becomes your c. So 3 goes in the upper left box. The coefficient is going to be 4, -9, -8, and -3. This time there are no terms missing, constant, x1, x2, x3, so there's no placeholders needed. Draw our straight line, bring down the first term, and we multiply and add. Multiply, add, multiply, add. And as you can see, our remainder is 0, which means, therefore, 3 is a 0 to the polynomial f of x. Or I'll say of the polynomial f of x. Okay? That's by the factor theorem, because if the remainder is 0, that means that x minus 3 is a factor of the function. And if it's a factor of the function, then you can find the 0 by setting it equal to 0 and solving, and you get 3. So it all ties in to the remainder theorem or the factor theorem.